Example number 2. Sketch the graph of the function f of x equal x squared divided by square root of x plus 1. Step number 1, we find the domain, and the domain is all real number except for x plus 1 to be not 0 and have to be positive because it is the square root. So we solve and we get x greater than -1. Or we can write -1 to infinity. Step number 2, we find the intercept. So to find the x intercept, we will let y equal to 0. So that means that x squared divided by x plus 1 equal to 0. It means that x have to be 0. So we got the point 0, 0 is the x intercept. To find the y intercept, we let x equal to 0. And f of 0 is also 0. So the point 0, 0 is also the y intercept. Step number 3, we find the asymptotes. Now we're talking about the asymptote, the horizontal asymptote first. When x approaches to infinity of the function x squared divided by square root of x plus 1, the highest power of the x is x squared. So we will divide top and bottom by x squared. So if we divide it by x squared, is equal to x to the 4th square root. So when it goes inside the square root, it will become x to the 4th. So on the top is 1. In the bottom, we have 1 over x cubed plus 1 over x to the 4th. When x approaches to infinity, this goes to 0 and this goes to 0. So 1 over 0, we got infinity. It means that we have no horizontal asymptote. Now we will find the vertical asymptote. The bottom number is 0 when x equal to -1. So we will find the limit when x approaches to -1 on the right side of the function x squared, square root of x plus 1. And we also compute the limit when x approaches to -1 on the left side of the function x squared over square root of x plus 1. But you remember the domain. The domain we take from -1 to infinity. That means -1 on the right side. So when x approaches to -1 from the left side does not work. Then when we plug in -1 from the right side, we can think about this number like -0.9. When we plug in -0.9 on the top, we will get positive. In the bottom is also positive. So we get positive infinity. So the vertical asymptote is x equal -1. Step number 4, we will compute the f prime so that we can find the increasing and decreasing interval. We will use the quotient rule. So in the bottom, we will have g squared. On the top, we will have g, which is square root of x plus 1 times the derivative of the function f of x minus f of x times the derivative of g. So we have x plus 1 square root, that means 1/2. Then 1/2 x plus 1 to the 1/2 minus 1 is negative 1/2, and then the derivative of x plus 1 is 1. That means that we will have 1 over 2 square root of x plus 1. We will clean up a little bit. So we will have 2x times square root of x plus 1 minus x squared on the top, and then 2 square root of x plus 1. We will find the LCD. The LCD will be 2 times square root of x plus 1. So we will get 2 square root of x plus 1, and we have 4x times square root of x plus 1 times square root of x plus 1 is x plus 1 minus x squared. Then we simplify the one on the top. We will get 3x squared plus 4x, and for the bottom it will be 2x plus 1 multiply square root of x plus 1 is 3 over 2. If you want, you can factor this out. Step number 5, we will find the local minimum and local maximum. Before we find the local minimum and maximum, we need to find the interval, right? So then the f prime of x equal to 0, or f prime of x does not exist when if equal to 0, when x equal to 0 and x equal negative 4 over 3. So the numerator, right? And for the denominator, x have to be negative 1, and it will give us does not exist. Now we draw the number line, and then we're gonna put in negative 4 over 3, negative 1, and 0. You remember that the domain of this function is x have to be greater than negative 1. So we can take out all of this from negative 1 on the left side, and we just testing the point. We will get negative here and positive here. So the function f of x decrease from negative 1 to 0, and f of x increase from 0 to infinity. So step number 5 is the local mean and local max. So this will be the local mean. So local mean is x equal to 0. Then you plug in 0, you will get 0. So 0, 0 is local mean also. Step number 6, we will compute f double prime. So this will be a lot of work for us. Let's write out f prime in the product. So that is 3x squared plus 4x times x plus 1, 3 over 2 negative, and then we have 1/2. So I think about the product, and I want to apply the product rule. It will be easier for me than the quotient rule. We're going to pull out the 1/2. Then we will take the derivative of, I'm going to use this formula. F times g prime is equal to f prime times g plus plus f times g prime. Okay, so what is our f is this one, and g will be this. So I will get 6x plus 4 times x plus 1 to the negative 3 over 2 plus, we keep the f now, 3x squared plus 4x. Then take the derivative of g. We pull out the exponent down. X plus 1, negative 3 over 2 minus 1 is negative 5 over 2. And the u is x plus 1. When we take the derivative, it will be 1. Okay, now we're gonna write the exponent become positive. So this will be changed to minus, right? Minus 3 over 2. On the top will be 3x squared plus 4x. And in the bottom will be x plus 1 to the 5 over 2. You know that 3 over 2 plus 1 is 5 over 2. So the LCD will be 2x plus 1. So 2x plus 1 to the 5 over 2. Now we multiply this all together. So we will get 12x squared plus 20x plus 8 minus 9x squared minus 12x. And then we simplify this. We will get 3x squared plus 8x plus 8. So we want to find the zero of f double prime to find the concave up or concave down. So f double prime of x equal to 0 when the 3x squared plus 8x plus 8 equal to 0. But we notice that we have the discriminant b squared minus 4ac is negative 32, which is less than 0. So we have no solution. No solution, that means we have a parabola, and the parabola does not have the intersection with the x. And your A is positive, so your parabola is open up. So your parabola must be like this. Okay, if your parabola is going down like this, when you extend, it will touch in the x, and then we will have the solution. Since we have no solution for the discrimination negative, that means that the 3x squared plus 8x plus 8 always positive. Okay, so on the top is always positive. In the bottom, since the domain x greater than negative 1, so it's also positive. So f the parameter of x cannot be 0, it will be always positive. That means we will always have concave up. Now the next step, we will use the information above to make the graph, and we also have no inflection point because we don't have concave up and concave down. Now we will graph the asymptote first, right? The asymptote is x equal negative 1, the vertical asymptote. And then the next one is the point. We have the X intercept, also the local minimum. So we go back to this information. The vertical asymptote is only happen on the right side of -1. The left side of -1 is does not on the domain, and is an approach to infinity. So that's why it's go up. So we need to connect the point 0. So it have to be go like this. And since 0, 0 is the minimum, so the local minimum, so our graph have to be go up like this.